So basically, with RIP, we're saying that it does the metric is hop count. But the funny thing about RIP is that even though RIP is a good protocol and all that, it can only travel up to 15 jumps, meaning 16 routers. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. When I say 16 routers, this is what I mean. From one router to the last router, it cannot be more than 16 routers. So it means that we can also have maybe if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can also have 11, 12, 13, 14, 15, 16. Meaning this guy can 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This guy can still go here. This guy can also go here. It means that if you have a diameter, the length of your network shouldn't be more than 16 routers. It doesn't mean that you need only 16 routers in your architecture. It only means that if you look at from one device to the last device or any other device, when you're looking at the number of hops, it shouldn't be more than 15 hops, meaning from here to here shouldn't be more than 16 routers. And so it means that RIP is not always ideal. So it can only be used for small organizations that don't have a lot of devices, even though 16 routers on one line in that diameter is enough. But trust me, I'm talking about, I've worked on a project where we had more than 2,000 routers. So 16 routers in one line is just normal. And for such a case, we couldn't use RIP because RIP will not work well, because some devices will not be receiving the routes because they are far away from it. Later on, I'll demonstrate that, or when you have the time, you can also demonstrate that on your own. But in such a situation, the kind of protocol you would want to use is maybe OSPF or EIGRP, because they can do OSPF, for example, will do it doesn't have a limit in terms of the number of routers, but with EIGRP, it has up to 255 hops. So again, anytime you're doing networking, you need to also look at all the technologies you're using and then which one will solve the problem at which time. You don't want to use OSPF for a very small network because it doesn't really mean anything. You'd want to use maybe static or RIP. And so you need to consider why and when you use that. So RIP is used for small organizations. Also, every 30 seconds, the entire routing table is sent. So this is what it means. Now, let's say I'm the router and I'm telling you about the networks, and I say, hello, my name is George, and I know about 10 network. Then I come back again and say, hello, man. After 30 seconds, I'll come back to you, the next router, and I'll say again, hello, my name is George, and I have 10 network. After 30 seconds, I come back again, hello, my name is George, and I have 10 network. Nothing has changed, but I keep coming back to you every 30 seconds. That's the disadvantage of RIP. Because with RIP, all it does is that it tells you all the things you know about every single time. It repeats itself. So that is a lot of bandwidth utilization. So think about it. How would you feel if somebody comes to you every single time to tell you something you already know about? You get fed up. And that's how RIP makes the devices behave. They get overwhelmed because it's just utilizing the bandwidth every 30 seconds. Another thing about RIP is that it also does it also has, every routing protocol has something called an administrative distance. So administrative distance is just how believable something that someone tells you is. So if I come to you and I tell you that, hey, maybe somebody in your family is traveling today. If I tell you that, you may take it in, you may want to process it. But if somebody within your family comes to you today and say that, hey, it's not true, nobody in our family is traveling today, between myself and the other person coming from your family, it is very possible that you believe your family member over me. It's not because you don't trust me, it's because your family member is closer to you. So the level of trust you have for your family member is higher than the level of trust you have for me. But in terms of routing, administrative distance is more like what we call the trustworthiness of what a router tells you about a particular network it knows about. So if R1 tells you about 10 networks and says that, hey, I know about 10 networks, using RIP, the value that will be assigned to this particular 10 network is 120, saying that, hey, I know about RIP. And because I know about 10 network, and because I'm telling you using RIP, if you want to trust me, this is the trust level, 120. Now, the lower, the better. So if somebody configures this same 10 network on this device, because this 10 network was being told by R1, but if somebody configures 10 network statically on this device, now, once you configure a particular network on a particular device, that particular network you configured on that device will have an administrative distance of 1. RIP is giving you a default administrative distance of 120. Static is giving you administrative distance of 1. The thing is, the lower the better. It's like saying the closer to a lower number, the better, because with administrative distance, we're looking at how trustworthy that person is. So the lower the number, the higher the trustworthiness. And so if somebody get a device gets to know about a particular network based on RIP, and it knows about that network also based on the fact that a network engineer configured it, the device will take what the network engineer is saying because it will have an administrative distance which is lower than what RIP is saying.